My dear students, today we will discuss about some problems related to ELTI systems. In the previous video lecture, we discussed about the properties of ELTI systems. What are the conditions, whether the LTI systems are causal or not, or it is stable or unstable, that we have discussed some properties of those ELTI systems. What are the conditions for stability of ELTI systems? Causal, stable, memoryless, dynamic, all the conditions we have observed, we have discussed here. Now what we'll do in internal in internal or in exam, sometimes what they will do, they will not ask about the properties, they will give some equations, like they have give some equation, ask you to find out whether these systems are stable or not, causal or non-causal. They ask you to find out that one. For example, we'll discuss some problems. For example, verify whether the following systems are Bibo stable or not. For example, h of t equal to 1 by rc e raised to minus t rc for t greater than or equal to 0, and it is 0 for t less than 0. First we'll analyze this problem. We'll find out whether this is stable or not. Therefore, this is equation is what? H of t equal to 1 by rc into e raised to minus t by rc. Here this is causal system. Since h of t is 0, here you see h of t is 0, t less than 0. Because what are causal systems? Causal systems are the systems output of which the system whose output is which depends on the present and past inputs. Its output, if it depends on the future inputs, then such systems are called as non-causal systems. Since what is the condition in causal? While discussing about the properties of the system, also we have derived a condition that if the system is causal, when the system is causal, when h of t is 0 for t less than 0, then such systems are we can call as causal system. Already in the problem they have given this for t greater than equal to the t greater than equal to 0, then this is the equation, and it is 0 t less than 0, then it means it is a causal system. Next we'll find out for stability of a system. We will find out the stability of system. What is the equation to find out the stability of a system? What is the condition? Here above only it is there. A LTI system is stable if stability. What is integration of minus infinity plus infinity modulus h of t dt? If it is less than infinity, then such systems we can call as stable systems. Here h of they have given h of t. Therefore, integration of h of t dt equal to integration of minus infinity plus infinity. What is h of t? Here what is h of t? Here h of t is 1 by rc e raised to minus t by rc. Put place that value of h of t in this equation, then we'll get h of t as it is equal to integration of minus infinity to plus infinity 1 by rc e raised to minus t by rc dt for t greater than or equal to 0. Then what we'll do, this since that is 1 by rc is a constant, and also we have changed the limits of integration. Why? Because this is true when t is greater than or equal to 0. Therefore we'll change the limits of integration as it is. Equation holds good when t is greater than or equal to 0. Therefore we'll change the limits of integration as integration 0 to infinity 1 by rc e raised to minus t by rc dt. Then here what happens? 1 by rc is a constant. We'll take outside and we'll do the integration. When we do the integration of e raised to minus t by rc with respect to t, then this will be, we'll get like 1 by 1 by minus 1 by 1 by rc because when we do integration of this, then we'll get this, like with respect to t, we'll get this, and then it is as it is, e raised to minus t rc, integral, apply the limits, that is 0 to infinity. When we apply this, then we'll get the result as like this. We'll get the result as like it will be 1. It will be 1. Why? Because it will be 1. Then you analyze that one. You go on analyze this equation. You will come to know that is, if here you see here, suppose this RC goes up and this RC is in the denominator, this will be in the numerator, therefore get cancels. When we apply the limits to here to this equation, that answer will be 1. 1 means it is less than infinity. When it is 1, you are definitely, we know that 1 is less than infinity, 100 is less than infinity, 1000 is less than infinity. Therefore 1 is, anyhow, it is less than infinity. If it is less than infinity, then such systems are called as LTS systems. Such systems are called as, such systems are called as these systems are called as stable systems. Hence this is stable. This system is stable. Why? Because this is the condition. It's a integration of minus into plus into h of t dt, if it is equal to less than infinity, then such systems are called stable systems. This is stable and it is causal also. Next we will see one more problem. One more problem is what? Find out whether this system is stable or not. That is what? H of t equal to 1 by under root LC sine into minus t under root LC for t greater than or equal to 0, and it is 0 for t less than 0. We will find out whether the system is stable or not, causal or not. Therefore, in this equation they are given, that is h of t is what? 0 for t less than 0. If t is less than 0, then this equation is definitely, it is causal. If it is some value for h of t is having some value when t is less than 0, then such systems are not causal systems. Therefore, this is the condition for causal system. That is, h of t should be 0 for t less than 0. Therefore, this is a causal system. Then we found out whether it is causal or not. Okay, it is now we'll find out whether the system is stable or not. What is the condition for stability? The condition for stability is, let us evaluate. The conditions for stability is this equation, integration of minus infinity plus infinity h of t dt. It should be whatever value we get, that should be less than infinity. Then such systems we can call as stable system. Now what is integration of minus into plus infinity h of t dt is equal to, here what is the value of h of t? Here what is the value of h of t? H of t equal to 1 by under root LC. This is, such equation is there for t greater than or equal to 0. This will take this one, h of t equal to integration of minus into plus infinity and 1 by under root LC sine into t minus under root LC dt for square root, that is 1 by square root of LC sine into minus t by square root of LC dt for t greater than or equal to 0. Then it is equal to 0 to infinity. We have changed the limits of integration. Why? Because you see in the problem, this will be, this equation holds good for t greater than or equal to 0. If it is t less than 0, then this is what is the output? What output is 0? When h of t is less than 0, output is 0. This h of t is equal to this for t greater than or equal to 0. Therefore, what happens? We have to change the limits of integration. This is for t greater than or equal to 0. Therefore, you change the limit of integration equal to 0 to infinity 1 by square root of LC sine minus t divided by square root of LC dt. Now what we'll do, let t by square root of L is equal to p. We'll assume that one, this is equal to p. Hence, do the differentiation, then dt equal to square root of LC dp. Means dt by and do the then this rearrange that one, then dt equal to square root of dp. Then hence above equation becomes what happens, above equation how we can write, that is integration of minus into plus into h of t dt equal to integration 0 to infinity 1 by square root of LC sine minus p. Why minus p means that is t minus tau. This here minus here we have taken this t minus square root of LC we have taken as considered as p. Therefore equal to sine, this is sine minus is the sine minus p. Then square root of LC. Square root of LC. Why? Because this dt is what? Here dt is there. In place of dt we have to put this value, that is square root of LC dp. Square root of LC get cancelled. We are left with only that is what, sine p. Uh, we'll get sine p. Then take outside minus, then sine p dp. It should be the how to mention dp, I think. Okay, minus integration of 0 to infinity sine p. Then what is the integration of sine p? Then sine integration of sine is minus cos. Therefore minus cos p. Apply the limits 0 to infinity. Therefore minus becomes plus. Then apply the limits cos infinity minus here cos 0 is how much? Cos 0 is 1. Therefore cos 1. Cos infinity is that value is also less than 1. Therefore the value of cosine of function is always from the value of cosine of any value is in between minus 1 to plus 1. Therefore definitely will be it is less than 1 only. It is less than infinity only. Therefore hence this will be integration of minus into plus infinity h of t dt is always less than, it is this equation is less than infinity. Why? Because cosine of function of any value is in between minus 1 to plus 1. Whatever that, it is between minus 1 to plus 1 means definitely will be less than infinity. Therefore this system is stable. Therefore this is a stable system. That is how we can find out whether the following system are stable or not, causal or not. When they are given the problems like this is about impulse responses. These are the some examples related to continuous time signal. Suppose even though we can how to solve some problems, they will ask some problems related to discrete time signal also. For example, I will solve one problem related to discrete time systems. Sorry, I am telling signal. All here it is discussing is not about the signal. Here discussing about the systems. The impulse response of a system is h of t. Once again, h of t. This is also related to convolution integral only. Okay, no problem. one problem related to determine whether the system described by the following are stable or causal. For example, one problem will discuss related to discrete time signal. For example, h of n equal to 1 by 2 raised to n u of n. Then we will find out whether this system is stable or not. Here u of n is what? Unit uh, unit sample, you know, that is unit step is there, like unit sample signal is there. It is u of n is unit sample signal, whereas u of t is what? That is unit step function. Already in the different types of signals we have discussed about that. Then h of n is nothing but unit sample response, which is equal to 1 by 2 raised to n u of n. Then causality, we'll find out the causality of this system. The system is causal if h of n is 0 for n less than equal to 0. This system is causal since u of n is equal to 0. U of n is equal to 0 for n, that is u of n exists only from towards positive axis. U of n will not be there towards negative axis. Therefore, this system is causal. It is unit step function. Unit step h of t is u of t is what? Unit step. Already in discussing about the various types of signals, we have discussed that u of t here, that for continuous time, u of n for discrete time. Unit samples, that is it will exist towards only positive axis of time axis. Here n means number of samples. If it is u of t, then signal which is existing towards positive axis of the time axis, that is u of t. Here u of n, so many number of samples existing towards positive value of n. Therefore, towards negative, if n is less than 0, then what is the value of un? 0. Therefore, since un is 0 for n is less than equal to 0, then such systems are, this system is causal. Why? In the equation we are having u of n. Therefore, we can call this system as a causal system. Next, we'll find out whether the system is stable or not. Then, for considering, to find out whether the system is stable or not, this is the equation. Here we have to take summation. While finding the stability of a system which is in continuous in nature, continuous time signal, at that time what we have taken, that is integration of minus infinity plus infinity h of t modulus of h of t dt. Like, but here, since the signal is discrete in nature, sorry, system is discrete in nature, then what we have to consider, we have to take the summation of k equal to minus n plus infinity modulus of h of k. Here, what is h of k? H of k, we have to consider what is the value of h of k. H of k, this is the equation, and this is 1 by 2 raised to k. Replace n by k. Therefore, this will be 1 by 2 in place of n, k in place of that is u, it will be uk. Therefore, this will be equal to summation of k equal to 0 to infinity. We change the limits of summation. Why? Because this is existing only when n is greater than or equal to 0. It is not existing because when n is less than 0, since it is u of n is there, therefore only this is applicable only when k equal to 0 to infinity. Minus n, the system will not give the result. Therefore, we have to change the limits of summation, that is equal to k equal to 0 to infinity 1 by 2 into raised to k. Then when we do that one, some equation formula is there. At that time, we have to use the formula. I think in the previous problem they have given the formula. Formula is that, using that formula, if summation of like this is there, then it will be equal to 1 by total summation k equals 0 to infinity 1 by 2 raised to k is there. Then using some formula is there. Use that formula, that will be equal to 1 divided by 1 by 1 minus 1 by 2, 1 by 2, then it will be analyze, rearrange, simplify this equation, will get result is 2. Hence, the here, here, therefore, hence this system is stable because it is less than infinity. Anyhow, if it is less than infinity, what is the condition? Here also we know that if h of this is h of in summation of, also while discussing about the stability of a system, summation of k equal to minus into plus infinity h of n, it is, if it is less than, result is less than 0, then such system is called as stable. Here also the value is 2, means it is definitely is less than infinity, therefore this system is also stable system. For this, how we got this equation, I think in previous, here we have come across that equation, I think. Okay. Here it is there. Here, here, here let us use the standard formula, that is summation of k equal to 0 to infinity, k ak is there, then we can write this as a 1 by 2 1 minus a raised to square. Like this we have to use this formula. I think this is the formula that we have to use to find out that. Right. Like such formulas you have to use to solve the problems. Also, what is the condition while discussing about the condition of your stability of your LTS system? What is the condition for, here is the condition. Summation of k equal to minus infinity plus infinity, modulus of h of k, if it is less than infinity, then such systems are called as stable system. It's unit impulse response, unit sample response, when it is equal to, value result is less than infinity, then such systems are called as stable systems. Okay, such problems, so many problems in the internal, they have given so many problems. In question bank we have given so many problems related to this, find out whether the systems are stable or not, causal or not. So 4 5 problems related to continuous type, 4 5 problems related to discrete time systems. Therefore, you only have discussed one or two examples. Go through my notes. The problem, so many different problems are also there. And but but your question bank, they asked the problems totally different. Why? Because there they have given the problems from the standard book, that is Allen Oppenheim. Velsky, that standard book is there, no? I think from that book they have given the problems, solved and unsolved problems. You refer those problems. Only thing is that you have to apply such conditions and find out whether the systems are stable or not, causal or not. That's all. Those problems are simple. Only those are the problems are from, that is Alan Oppenheim, that author standard textbook. From that problems are there. You apply these conditions. Steps will be same. The conditions are same. Only the problem is different. Different problems are there. Concept same, procedure same. Only the problems are different. Okay, we refer the book, that is Alan Oppenheim, the textbook, whatever they have mentioned in the syllabus, which is mentioned in the syllabus, you have to refer that for internal, because here I discussed so many concepts, but all here it is there is somewhat different problems. But in this book, Alan V. Oppenheim, this is a textbook, your standard book, which you have to refer. That is Alan B. Oppenheim, S. Velsky, and H. Nawab, Signal System. Pearson Education 2007. This is the standard book. Other sirs, lecturers, professors, they are referring this book, and the question bank, whatever they have given, I think those problems belong to this textbook only. You refer this textbook. In there, they might have given the solution related to all these concepts. Okay, but pressure will be same. Pressure is same, but problems will be different. Okay, there is a few more video lectures that is related to difference and differential equations, that one or two video lectures I will make tomorrow. Probably I make one or two lectures related to differential and difference equations. Okay. Now, if I do the video lectures related to then it is over. So two models are over, and it is will be useful for you to refer for the first major test or first internal test. Okay. Okay. Thank you.